Hello, this lesson is about quadratics, and it will be used, I should say, in my pre-college algebra class. The class is designed for students who have struggled but have passed Algebra 1 and 2, as well as geometry. The class lends itself to looking at problems from previous classes and deciding how to view the problems as they saw them earlier in that context, but then also getting a broader view of the tools developed and why they make sense. I work to get deeper understanding of the math they have seen rather than extending very much. I want them to solidify their thinking, not just the recipes or even the heuristics, but to feel some satisfaction and some success and some ownership before they do spend their money on college algebra the next year or when they leave high school. The course works best when students have more time to think about the work and less stress on efficiency, although efficient use of skills is one of the goals. So being able to communicate, use time effectively, just a lot of little things that tend to have caused these kids to struggle academically. I like the steps we took in our group to define mathematics. I plan to have students define and later modify if needed as we proceed through the semester. So I'd like when they leave after their senior year, it's kind of a capstone class for the generally lower end students, but what does mathematics mean to them and how might they use it? For our group, we used a process of studying and identifying patterns or relationships, typically to apply in some form, like an equation, visually, words, to predict outputs for given inputs. This lesson comes after working in small groups and learning methods. So the work that we're going to be doing is after they've learned undoing squaring. You have to consider the positive and negative values. We've done factoring, completing the square, from completing the square, the quadratic formula, and we've looked at graphs for a variety of polynomials, but really just to get a visual of it. So the class, this will be on the board. This is our goals, and this is pretty much the goal I have for every lesson. My goal is that they think and be able to share their thinking. So for this lesson, we're going to use the features that they might understand or have seen for quadratic equations, the methods they've used to solve the quadratic equation, and then their ability to interpret answers or verify they were correct. These are the ways that their ultimate goal is achieved, to learn how to think and share their thinking. So we start off, they'll see the black part there. Our goal is to understand the problem, and if I put this on the board, and if I don't even put this here, I'm expecting kids to make some assumptions, but I'm going to use the expression, what do you notice? And generally, they're probably going to think we're solving, which is correct. Um, but I like the idea. I've been in some classes where we talk about, like, what would you like to know about either a drawing or an equation? So it gets kids thinking, what is the context of this? What is something that they can connect to? And then from there, it gives them some confidence to make an attempt on what the problem actually is. And again, in this case, it is going to be to solve for x. Uh, can we solve it is an obvious question, maybe. Can we graph it? Not so sure. I'll see that one. What would you know about the equation? What would we know about the equation if we did solve it? And so if there was a word problem, if there was some context, what does the solution actually get us? These are things that I'm going to throw out there over the course of the semester. So if I change this now to solve for x, given this equation, um, I know that students have seen similar problems, and so they're going to, in some way or another, basically say, what's the value of x that makes the equation true? Um, although there is only one variable, we can't combine the terms easily to get x by itself. This is typically something I have to remind them of. The graph is a parabola, even though this isn't real, it's not a y equals. We use Desmos, which automatically turns things into graphs. Um, for the use of what we're trying to get done, that works for us. We usually get two answers when solving a quadratic. That would be something, since previously, within the last week and a half, we would have done some graphing of polynomials. And then this is covered after, that's that. So now we move on to devising a plan. So if we say we know what we're being asked to do, solve for x, which means get a value of x that makes this equation true. What problems have we solved like this? And how did we solve them? That's going to be the way that we develop this plan. And then they're going to work in groups. Take 5 minutes in your group to discuss ways to solve the equation. Some of the things I'll be reminding them as we discuss and before I let them loose. When we have x squared but no x term, we can just undo the squaring. We do have to remember there's typically two values, a positive and a negative, unless it's a zero there. When x squared with an x term appears, so now it's not a 0x, it's got a number in front. We get the x's by themselves and factor or complete the square. That's typically what we've done. We can use the quadratic formula anytime we have x squared or graphing if we are allowed to use technology. I'm thinking this is really what I want them to do to get answers. So as we begin this process, I'm going to be guiding them a bit to avoid the quadratic formula, avoid calculators, but if they get started that way, I'm going to work with it because I'm going to have multiple groups, so there'll be some exchange that can help bring out an order that makes sense. So once they've had that time, each group share one method that you think makes sense in solving this problem and why you chose it. I'll remain at the board with this information here, and I'll be writing down the different methods. Typically, we have team names or group names, and so I'll put the group name and the method that they chose, the words that they gave me. I won't be solving it. And then we're going to execute the plan. So once they've got those the methods written out there, if some people were struggling and they need some help, they'll see some other methods that they could adopt. Now that you have a method, how will you know if you were successful? Each group solve, allowing any questions so that anyone in the group can explain how you did your work. Basically, don't let one kid do all the work. If I see a scribe, that person then is, I'm typically not going to ask them the work they did. I'll be asking someone else who uh, shouldn't have their phone out. They should be contributing to the process. So with a thumbs up, we complete the task. As each group completes the work, I walk around while it's getting worked on. I ask them questions about their process, or the students that don't seem maybe quite as engaged, verify that they're following along, facilitate, see if they have any answers, and then if needed, find ways to prepare mentally as they give those answers that the answer is going to be incorrect, but how they got there. So that'll be a pretty valuable thing. I expect some groups to struggle. The lesson will be successful if they try at least two methods. I don't mind wrong answers. In fact, I like them. It gives me a chance to explain common mistakes. But students tend to feel bad when they present wrong answers. So I'm typically going to be doing the work at the board. I usually get a kid or two that does like to go up to the board and they don't mind being wrong. Kind of depends on how the class goes. Depending on the comfort level of the class, I may perform their work on the board or have selected students kind of work with that. Really, it's more volunteer students I think I'll do in this case. To look back, we tend to spend a lot of time on factoring, so I purposely chose one that doesn't factor so they get more practice on completing the square. I'll go around the room asking groups to say whether they got an answer and if they think it's correct. For those that did solving by completing the square, um, I'll ask how that went for them. They should have all the work of getting the variables by themselves, taking the b over 2 squared, adding it to both sides. That'll be my hint. If kids go, yeah, I know it's completing the square, but I'm not sure. So then they'll follow through on the work, get two answers. Um, we'll, I'll ask them, what is the number square root of 5 minus 2 or negative square root of 5 minus 2? And we'll talk a little bit about how square root of 5 is some number between 2 and 3, probably closer to 2. Um, I don't mind these answers, but I want them to have a relative sense. You know, what is it closest to, or what two values is the square root of 5, or square root of 5 minus 2? What two numbers will that be between? Looking at the graph, So if we plug this into Desmos and we see that this value, if this is a -3 here, it's somewhere between -3 and -4, one of the values. And we'll have a discussion about which one of these would be the one that would be this answer here. It'll be the one that's a sum of two negatives. The other one, -5 minus root 2, we would think it's somewhere in there. They certainly seem like reasonable answers for our graph, so trying to make a connection there. Finally, I'll do the quadratic formula. We'll sing it, get that figured out. We'll go through. The form looks a little different. -2 plus or minus square root of 5. Take a quick look at how that compares to square root of 5 minus 2 and negative square root of 5 minus 2. It's the same thing. And then finally, it's part of the look back. If your group could change one thing about this problem, make it more interesting, less difficult, impossible, etc., what would you do? And the reason this is in here, and this is a new idea for me, it's not going to be super efficient, but it's where I want kids to be. I'm realizing that too often my students, and really students in general, don't feel that they are able to affect how the class goes. But I want them to have the buy-in. So I have to get through enough material to get them to be prepared for college algebra. But this coming year, I'd like to have them develop more ownership. So if they have a problem from a physics class that comes up or those kinds of things, I'm going to be trying to find ways to do that. I've tried to raise the interest level in the past by doing a buy a car module, but they tend to do the interesting part of looking at cars and they ignore the uh, uh, exponential equation stuff and how payments work. We don't do shit to geometrics in this class, but trying to figure out what's going to be a good idea for reliable vehicle or one that you look good in and how much interest you'd be paying. Anyway, so they tend to, I had hoped they'd be interested, but they don't typically. Maybe we'd have more, how would you change things problems to get them feeling that the course is more about their thinking and less about following a recipe. I'd like this kind of a question to stick with kids so they realize I really do care how they're processing, what's going well, what isn't, and what they think. So the last thing, I guess now, what if the problem were changed to, so this is depending on feedback, I'll give some ideas on how we could have changed it. If I change this to a +1, we're going to do a -1 over there. We get imaginary numbers. If I change this from a 4 to a 5, it's an odd, and 5 doesn't cut in half easily in square. For this equation, x squared plus 5x minus 1 equals 0, if I said give the name of the equation and how many solutions you expect, this gets it tougher, and it really just talks about what you could memorize or actually look up. So this is the kind of question, might come up on a standardized test, but this is not the kind of stuff I really push. And then finally solve x squared minus 1. This one would be easier because we don't have that linear term. We don't have to complete the square. We just undo. So that's my lesson. Appreciate your feedback.